Okay folks, sorry about the issues here. I'm going to try and avoid using the calculator where I bring it up here, because every time it seems I'm doing that, that's when it's shutting down. So I'll try and explain what's going on in terms of the commands on the calculators if need be. So my apologies for that, but hopefully we can finish this out from here. So we have the heights of women in college follow a normal distribution with a mean of 65 inches and a standard deviation of 2.5 inches. So that, notice that's mu equals 65 inches and sigma equals 2.5 inches. And we already solved the other two problems. Let's finish off this third one. And so what we have in our calculator, we have a nice command. It's called the inverse norm command. And so we want to find the tallest 5%, which would be over here, right? You can also consider this percentiles, the top 5% or something like that. Percentiles would be talking about on the other side of the thing, the 95th percentile is essentially what happens. 0.95 is what we're dealing with right there. So now the command that we use in order to get our z-score is this inverse norm command. And so it only deals with stuff to the left, and so I hit inverse norm of 0.95 and I can get an answer. Now I wouldn't round this answer, I'm going to round it here just for the sake of making the writing a little bit simpler. So now what this represents, this is our z-score. Okay, so with our z-score we have 1.645 equals, now it goes x minus our mu divided by our sigma, which, notice that means 1.645 equals x minus our mu and sigma are given up above, minus 65 divided by our 2.5. If you multiply both sides by 2.5, notice you get 1.645 times 2.5 equals x minus 65. And so our x value equals 1.645 times 2.5 plus 65. Okay, now I'm going to just type that out in the calculator here, times 2.5 plus 65. Now in the calculator I didn't do any rounding with the z-score, by the way. So I just wrote it down that way just to make life a little easier. So what we get as our x value is 69.112, and that would be inches. Okay. Whew. Hopefully we're finally off this page. Hopefully we'll have some good luck from here on out. Okay, so now we're getting back to expected values and things like that. So in terms of this problem, we have the table below summarizes the number of surface flaws found on the paintwork of new cars following their inspection after primer paint was applied by a new method. So we have 0 flaws being 5 cars. There's 9 cars with 1 flaw, 14 cars with 2 flaws, 12 cars with 3 flaws, 6 cars with 4 flaws, 3 cars with 5 flaws, and 1 car with 6 flaws. So how do we go about doing this? Well, first things first, we need to talk about, when we're trying to find the mean number of flaws, or this is an expected value, we need to find a probability. So in order to do that, we need to find a total. Well, the total, 5 plus 9 plus 14 plus 12 plus 6 plus 3 plus 1, that makes 50 cars. That means our probability of each can be calculated. So our probability of x, essentially. So the first case would be, I'll write them on the sides here, 5 over 50, or an easier way for us to do that is 0.1. The next one would be 9 over 50, which would be 0.18. Okay, and we can go on down the line. So you get 0.28, 0.24, 0.12, 0.06, and 0.02. Yeah. Oh, so someone says that they still see me as offline. Hopefully you can see me as online. Please verify if you can. So it's stating I'm online from my live stream. So hopefully video is still going through. I don't see a response either way. But so in terms of, we have our probabilities now. What you want to do is actually try and use that little table to, or you can do sum of x, p of x. So the first case, what we're looking for is an expected value of x. So remember, that's the sum of x times p of x, right? Or you can use a table to do that. Okay, the way to do a table, you'd insert in your list 1 all your possible values, your 0, 1, 2, 3, 4, 5, and 6. And in your second column, you'd list the probabilities. Make sure it's for probabilities and not numbers of cars. So you'd want the 0.18, or I'm sorry, the 0.1, the 0.18, the 0.28, the 0.24, the 0.12, the 0.06, and the 0.02. Okay, so those should be your values that you're seeing in there. All right. So now moving forward from there, now that we have those, you go to your stat. After hitting stat, there'll be a calculate in the second column of the row, and then you'll see one var stats. Under one var stats, you'll hit L1, comma L2, and then you'll get your answers. And the answers that'll come up from that, so you get this for the mean. You'll get 2.36 by plugging that in. And that's just taking 0 times 0.1, 1 times 0.18, plus 2 times 0.28, plus 3 times 0.24, plus 4 times 0.12, plus 5 times 0.06, plus 6 times 0.02. Okay, so now we have that. The other piece of information that you get, now this wants to find the variance. We do have the standard deviation. We have the sigma of x equals 1.42492 and then 105. So the variance is just taking that standard deviation and squaring it. Okay, so all we have to do is type into a calculator that number. And my apologies for not having the other calculator up, but I've been having some difficulties with that live stream. So in terms of what we have as our final answer, we get 2.0304 as our variance, just by taking this and squaring it. Okay, so taking this number, squaring it, gives you that answer. Hopefully that makes sense on that part. Alright, so now making a transition, we're going to move into the binomial distribution. So we've seen normal distribution, we've seen the random variables and all that stuff. The binomial distribution gives some people some trouble, so I want to try and clarify that. So a problem here is Blue Sky Air has the best on-time arrival rate with 80% of its flights arriving on time. A test is conducted by randomly selecting 16 Blue Sky Air flights and observing whether they arrive on time. What is the probability that 2 flights of Blue Sky Air arrive late? And then it says, please carry your answer to 6 decimal places. So that 2 flights arrive late. Now, this is a binomial distribution problem. Okay. And the way we approach this one, because events are independent, that's the whole song and dance in terms of the reason why. So distinguishing that is a part of the trick. But usually normal distribution problems are going to come out and say normal distribution, and random variable problems will usually give you what the random variables behave like. Okay, so we're dealing with a binomial distribution problem. Now the thing that we need to know, we can talk about how your calculator does it, and then we can also kind of go through what actually happens. So in terms of how this works, where do these things come from? it's called a combination. And this is getting a count on the number of possible ways this can occur. So CNR, what the heck does that mean? So there's a formula. You go n factorial over r factorial n minus r factorial. And in this case, it gives you a count of how many different possibilities for this. We want to know 2 flights arriving late, right? So the combination that we're going to work with, there's 16 blue sky flights. So 16 there. And then we have 2 of them arriving late. So we want to put 16 comma 2 because of the 16 we're choosing 2 of those to arrive late. That's what's happening with all this stuff, okay? So now, moving forward from there, what does the formula look like? Well, we get 16 factorial over, this will be 2 factorial, and this will be 16 minus 2 is 14 factorial. Okay, for those of you that don't know what factorials are, this would be like 16 factorial, 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. Now I can figure out what all those factors are, but there's a nice easy way in the calculator. If you hit the math button, and then after you hit that, you can go to the probability and there's an NCR. Well, if you put the 16 before that and the 2 after that, you can get there pretty easily. So when you actually work this out, you get 120 for your answer on this. And so our probability, what do? Well, we just basically take the number of possibilities, possible ways we can have 2 flights arrive late. Okay, now think about this. We want on-time arrival for 14 of those flights and 2 of those to be late. So the way we do that, we'll go 0.8 raised to the 14th power, because that would be multiplication principle that many times. And then 0.2 of those, because that's the, not on time. So this is the on-time arrival. And this is the late arrival. And we want 2 of those. So this will be the probability. So you can take 16 comma 2, that's 120. And then we go times 0.8 raised to the 14th. And then times 0.2 squared. And we get our final answer. It wants how many decimal places? Give your final answer to 3 decimal places. So this is 0.2111. So 0.211. Alright, so was this the only way to approach this? Well, no, by no means. Your calculator has some very nice commands in it, and under the distribution, so hit second where you see the vars, there's a distribution is what that stands for, the DISTR. So there's one called a binom PDF. Okay, so the thing you want to start with on this is you start with this given number of parameters n and p. Well, what's the n? The n is 16 in this case, so you can type in 16. And then we want, actually, so this is going to be slightly different. You're going to be using, so even though you see 80% here, the last condition, the number that we want to do arrive late, is 2. So that means we want this probability, since this is late arrivals, this is a probability of arriving late. If we put 0.8 there, right, so this would be also the same thing as binom PDF. We could put 16. If we put 0.8 here, we need to figure out the number of on-time arrivals. Well, that would be 14. So the PDF case is when we have equality. So this is 16 I'll do the 0.2 and 2. And notice when you punch that into a calculator, my apologies for not using a calculator again, but hopefully I won't get kicked off of YouTube Live again. But at the end of the day, if you use binom PDF, you'll get this answer of 0.211, which we see up there. Okay. So now let's see how we can kind of work these in terms of what's happening for binomial distribution. Suppose the number of TVs in a household has a binomial distribution with parameters n equals 19 and p equals 75%, which is 0.75. Find the probability of a household having 2 or 7 TVs. Okay, so in that case, what we can do is we can use combinations. So we have 19 to start with, 19 comma 2, and then we want having TVs is 75%. So we'll put 0.75 squared, and that means 0.25 will be raised to the 17th because 17 people won't have TVs. Plus, now that's the case for 2 TVs. In the case of 7 TVs, we would put 0.75 raised to the 7th and 0.25 raised to the 12th, because 19 minus 7 is 12. So that's where those numbers are coming from. But what a lot of you probably like to use is, this is an equality, binom PDF. You start with 19, you have 0.75, and then you want 2, plus binom PDF, and then you'd have 19.75, and in this case 7. Okay, so it's going to take me a second, and usually I would bring that up. If you're struggling to see it, I can bring it up, but we've been getting knocked off a couple times, so I want to make sure we're staying on. But I'd be happy to bring it up if you really need to see it. You aren't sure where it's happening in terms of your calculator. And so what would our first answer be? Let's see here. So our first answer, it's not going to be a large one. When you punch all those into the calculator, you get this 4.00905, 6102, and then you have an e -4. So what does that mean? That e to the -4 tells you you're going to have 3 zeros after a decimal place, and then you're going to put your number there. So that's exactly what it looks like. Questions on that? So our next case, a little bit trickier. In this case, we have 5 or fewer TVs. So the way we can go about doing this, we could do binom PDF and then use 19 comma 0 and then do 0.75 to the 0, 0.25 to the 19th, plus or I say binom, I could do binom PDF and 19.75 0. Then I could do plus binom PDF 19.75 1, plus binom PDF 19.75 2, and then yada 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 all the way to binom PDF 19.75 and 5, adding all those up. That's a pain, and luckily your calculator has a nice easier way to do this, and that would be the binom CDF command. Now remember though, what we're doing is just basically binom PDF for each of the scenarios, but the binom CDF is where you start with your actual value, number of possibilities, which is 19. You put the probability of it occurring, right? So 0.75. And then this last value, what we're dealing with there, it's the values that are less than or equal to that value. So in 5 or fewer, well, we just want to put 5 there. Okay, so what this means, remember, values less than or equal to. Now remember, this is binom CDF, not PDF. Okay. Questions on that? I know that can be tricky for a lot of people, especially with all the different commands. To give you an idea though, what we were doing C19, 0 and 0.75 to the 0, 0.25 to the 19th, plus C19, 1 times 0.75 to the 1, then 0.25 to the 18th, plus this command in the calculator is doing all these calculations. C19, 2, 0.75 squared times 0.25 to the 17th, plus so on and so forth, all the way up to C19, 5, 0.75 to the 5th, and then 0.25 to the 14th. Right? A lot of work, not too much fun punching all that in. So the calculator is going to do the work for us, and after we hit all these values, we get 1.152264303 negative 5. So what does that mean? Well, that means we have 0.0000, so 4 zeros, and then 115 is what we'd be punching in. Okay, so 5 or more TVs. Well, notice that last entry is value less than or equal to in our calculator. So the way we can approach this would be, we can't do 5 or more with the calculator. So the way to fix it is we'll do 4 or less, right, and subtract that from it. So this is binom CDF. So using our probability rules, we'll do 19, 0.75, 4, and we'll punch that in. So let's see what happens. We'll go 1 minus we have 19.75 and 4. And then on this one, we're going to need a lot of decimals in order to display it. 1, 2, 3, 4, 5. There's 5 nines, and I'll just write it all out. 8, 7, 5, 6, 8. For fewer than 7 TVs, notice the binom CDF would include 7 if we put 7 in that last column. So because it's less than or equal to. So the fix for that, we want fewer than 7 TVs. Well, the next magical number would be 6. So when we take a look at this, what do we get? We go to distribution, go to binom CDF, 19, 0.75, and then we type in 6. And remember, it's just dealing with all these combinations. So this is going to be 8.347905529E negative 5. So making sure that you can do these on your own, I'd be getting out a calculator and trying them out. So 8, 3, and then I'll round it here to 5. And so more than 5 TVs, so that means 6 or more essentially. That's actually not going to be too bad, because notice B already gave us 5 or fewer. So if we're doing more than 5, we just go 1 minus, we already have that answer, 0.000001. 0.0115. And so we get, in this case, 0.99988, and then 5 would be our approximate answer. So hopefully you're seeing it rock and roll and how we're just using probability rules and then making sure we can distinguish between the CDF, which is that last column will be the less than or equal to, and the PDF, which is just an exactly. So exactly that value. Okay. So now moving forward from there, we'll finish it off with this. And these look real scary. Don't let them fool you though. They're not too bad. So if x is a binomial random variable, compute the mean, the standard deviation, and the variance of each of the following cases. So these seem real scary, but they're not too bad. In a binomial distribution, here's all it is. Your mean is just basically taking your number, total number of trials, or whatever the case may be, and multiplying that by the probability. So since you only have one probability to deal with, you're pretty good to go. In our second case, for our variance, right, which will be this, I'll put an x down below, which they're using as sigma squared. They're using this as mu. I like to put the random variable down below usually. So in this case, it would be np times 1 minus p. So basically the probability of that event not occurring. And then so sigma x, or which we're calling sigma here, is just basically taking the square root of the variance. That's it. Okay, so keeping that in mind, we have n equals 5 and p equals 0.8. So in the case of the mu, you just take 5 times 0.8, and that one's not too bad. That's just 4, right? So now for the sigma squared, you take 5 times our 0.8, and then we also have to multiply by the probability it doesn't occur, which is 0.2. So just multiply that by 0.2, and notice you get 0.8 in this part. Now to take sigma, what do? Well, we take the square root of the variance. And this one I will need a calculator for. And so that becomes 0.8944. Questions on that? I know that seems kind of crazy, but that's basically what these are. So the next one, n times p, so you have n equals 3, and your p, your probability is 0.4, so that's 3 times 0.4, which is 1.2. The next one would be 3 times 0.4 times the probability of it occurring, which would be 0.6. You go 1 minus 0.4, you get 0.6. So notice if we take 1.2 times 0.6, we'll get 0.72. And notice this would be just the square root of the variance, so square root of the 0.72, and we have our answer of 0.8485. Okay, last but not least, and I appreciate you all sticking around, but if you have questions, let me know too. Don't let me get too far ahead of myself. But this last one, we're just going to take 3 times the 0.2, and so notice we get 0.6. Then for our standard, or for our variance, sorry, not our standard deviation yet, we take 0.6 times 0.8, and we'll get 0.48. And now if we take our square root of that 0.48, what do we finish with? We get 0.6928. And that is our final answer. So hopefully you've seen how the binomial random variables, actually I think those calculations of mean and standard deviation are a lot easier. But make sure you spend a lot of time. Binomial distributions, also normal distributions, a lot of stuff on that coming up on your exam. In the midterm as well. And then also just a regular random variable, how do we work on expected values, standard deviation, things along those lines. And I believe that does the most part right there. Okay. I don't see any more questions. Thanks again for joining in, and I'm sorry for the hiccups, the technical difficulties along the way. But if you do have any questions, please post them in the YouTube live discussion or shoot me an email, and I'll be happy to answer those. Okay, and good luck on the upcoming midterm as well. Have a good rest of your day, folks.